Hi, we're going to look at derivatives of exponential functions. So we'll look at several different derivative definitions. So we know for derivative of e to the power of x is equal to e to the power of x. So taking the derivative of Euler's number to the power of x doesn't change it. We get the same thing back. If we take the derivative of e to some function of x, then that's just going to be e to that function of x times the derivative of that function. So essentially utilizing chain rule. If we have derivative of a to x, that's going to be equal to a to x times the natural logarithm of a. If we have the derivative of a to a function of x, we essentially have the same thing, except for we're now going to have to take the derivative of that function as part of chain rule. So we would have a to that function of x times the derivative of that function times the natural logarithm of a. Okay, so this first one, we want to differentiate y equals e to the power of 3x. So y prime would just be e to the power of 3x times the derivative of 3x. So that would be 3e to 3x. Next, we have y equals 3 to the power of x to the power of 5. So y prime would just be 3x to the power of 5 times the derivative of x to the power of 5 times the natural logarithm of 3. Now, if the derivative of x to the power of 5 is 5x to the 4, so we've got 5 times 3 gives us 15. X to the 5 times x to, and then I realize I have not written this one super clearly. That should have been 3x to 5. So we've got 15 x to the 4 times 3x to the 5, natural logarithm of 3. And I realize that I once again didn't write this clearly. 3 to the power of x to the power of 5. Okay, next one, we've got y equals x squared times e to x. Now this one, we're going to have to use our product rule. So we have y prime is equal to d dx of x squared times e to x plus x squared times d dx of e to the x. So derivative of x squared is 2x. So we've got 2x e to the x. And then we've got plus x squared. And the derivative of e to x is just e to the x. Now, in this case, we have some things in common between these two. They both have e to the power of x. They also both have at least an x we can factor out. So I'll factor out x e to x, and that will give us 2 plus x. Next one, we've got y equals e to the power of sine x. So derivative of that would just give us e to sine x times the derivative of sine x. Now for derivative of sine x is cos x, we've got y prime is equal to e to power sine x times cos x. Okay, next example, we've got y equals 3x squared e to negative x. So y prime, we have a constant front, so we can move that in front of everything. And then we're going to take the derivative of x squared, multiply it by e to negative x, and then add x squared times the derivative of e to negative x. So derivative of x squared is 2x. And that's times e to negative x. And then we have plus x squared times the derivative of e to negative x, which is just going to be e to negative x. Our derivative of e to negative x would be negative 1, or sorry, to our negative x, because we have to follow through of chain rule. So that gives us y prime is equal to 3 times 2x e to negative x minus x squared e to negative x. Now, out of these, we can factor out an x and e to negative x. So that gives us y prime equals 3x e to negative x times 2 minus x. Okay, next example, we're going to find the equation to tangent line to the curve y equals e to power of x squared at x equals 1. So first thing I probably want to actually do is find my tangent point. So I'll substitute 1 into our equation for x. So that gives us e to 1 squared, which is just e. So our tangent point is going to be 1 comma e. We now want to find our slope. So we have y prime is equal to the derivative of e to x squared. So that's just going to be e to x squared times the derivative of that exponent of x squared. So that's going to be 2x times e to the x squared. So we'll find the slope when we've got f of 1. So it would be 2 times 1 times e to the power of 1 squared. So that's just going to be a slope of 2e. So now we can use our y minus y1 equals m times x minus x1 and fill in our values. So we've got y minus our y1, which is e, equals our slope of 2e times x minus 1. Okay, so we'll do one last example, and that is find the equation of a tangent line to a curve y equals e to 3x from the external point 0, 0. So first thing I'll do is find out the slope of our tangent line, or the general equation of it. So we have y prime would just be our derivative of e to 3x, which is e to 3x, times the derivative of 3x. So our slope equation is 3 times e to 3x. Now I'm going to refer to tangent point as xy. And we know that the slope of our tangent equals the slope of our line. At xy. So our slope of our tangent, I could elaborate a bit more as at the location x comma y. It's the same as our slope of a line as it goes through x comma y and 0, 0. So we know that slope of our tangent, we know we can write as y prime, and that's equal to y minus 0 over x minus 0. Now, y prime we determined was 3 times e to 3x is equal to y, which our equation for y is e to 3x over x. Now you'll note that both sides have e to 3x, so if we divide that out, we get 3 equals 1 over x. Or rearranging this, we get x equals 1/3. So we now know the x value of our tangent point. So now we need to find the y value of our tangent point. So that's just f of 1/3 is e to 3 times 1/3. So that would be e to 1 or e. So we know our tangent point is 1/3 e. Now to get our slope, we'll go y prime of 1/3, or we can also refer to that as f prime of 1/3 is equal to 3 times e to 3 times 1/3. That's going to give us 3e. So now we'll fill in our y minus y1 equals m times x minus x1. So that gives us y minus e equals 3e times x minus 1/3.